Hi, good morning. We are already running 10 minutes late, I guess. But we thought we have solved how a slide can be projected on the screen, but apparently not. Every time you go to a conference, something new comes up. But I'm glad slides are projecting well here. It's a beautiful venue, first of all, and I just love it. It's my first time in Belarus, so I'm excited. It's a very beautiful country. Love it, actually. So my name is Arun Gupta, and I work for Amazon. I am a principal technologist over there. I work in the open source team at Amazon, and I work with a lot of service teams in helping them define their open source strategy. So I would love to talk to you if you care about open source, if you care about AWS. I also work very closely with the containers and the serverless team in helping them define their strategy. So if you care about any of those things, Kubernetes or serverless or anything around developer tools, please talk to me. Like anybody and everybody, I have a Twitter handle, so my direct messages are open. I'm always looking forward for talking to developers. Well, so if you think about it, serverless, when developers think about serverless, they think about building functions. That I'm going to write my function, I'm going to upload the function, and the function will scale, and I don't have to manage the servers or clusters or anything of that sort by myself. But is functions the only level of abstraction? A lot of customers have been using containers all along. What about containers? How containers and serverless really blend with each other? What about, is that enough level of abstraction? What is the thing that are happening in the industry? What can we do at the infrastructure level to make that innovation better? So I hope to walk you through this journey where we'll talk about not just serverless from a function perspective, but containers and possibly beyond. Now, if you look at sort of how the computing industry has evolved over the years, go back to like not just too long ago, like 10, 15 years ago, you would need to get a physical machine. You want to install a software, so you go to your data center, say, hey, I want a new machine, download it, install it, provision it, patch it. Before that, you're going to have to actually get approval for the budget funding and all those things. So it takes a while for you to get going, and then you finally get your machine. So the innovation factor is pretty low, because if it takes 3 to 6 months to get the machine up and running, how fast can you innovate? That really slows you down. Well, the evolution happened from there, and then we started looking at virtual machines. So you have a lot of these big on-prem data centers, and instead of saying every time get a new hardware, you could ask for your IT team to provide a machine. That give me a virtual machine, and I'm happy to work with that. It kind of abstracts the hardware for you, but then you still have those virtual machines. Both cases, you call those people as server huggers, because they really hug onto the servers. They don't want to let go of their data centers. The third wave of computing, if you think about, is more towards containerization. And if you think of containerization, there are two aspects over there. One is where it provides a good packaging tool, where you can package all of your dependencies together into that one image, and then bring that same image across different compute environments and run it very seamlessly. And the second is it kind of cuts down the impedance mismatch between your dev, test, staging, production, and different environments, so that whatever you are doing in the development is what you're doing over there. There are no scripts that need to be run between different environments to get it up and running. So containerization really has helped a lot of customers. And then comes serverless. So this is where a lot of the industry is heading towards, where they're talking about, I only want to focus on my application code. I want to build my application code, I want to run it in the cloud, and let somebody else. Let me get straight. Serverless has servers. People think serverless means there are no servers. Serverless has servers. It's just that you are not responsible for managing them. The cloud that you're running on, or the data center that you're running on, is what is responsible for managing those servers. But from your perspective, I think what's important is where you have an application code that you upload it to a serverless platform, and there you go. Somebody else is managing those servers for you. The application just automatically scales. And lots of examples of that, and we'll talk about that as we move along. So let's talk about what really serverless means. Let's set that definition straight. First thing first, there are 4 tenets that we talk about when we talk about serverless. The first one is really no infrastructure provisioning. where you are looking at it that as an application developer, I don't have to go ask for a machine or an operating system, any of that. That all of that is gone completely. There is no management, no installing, no patching of operating system or scale your cluster first, then your applications can scale. None of that needs to happen. This is what we call as undifferentiated heavy lifting. You don't have to do that. Then comes the automatic scaling part of it. If we think from the containers perspective, scaling containers is good. They scale very rapidly. But containers still live in the land of a cluster. You have a cluster, and that's where your containers can scale. So what that means is in order for your containers to scale, your cluster has to scale first. In serverless, there is no such concept of a cluster. You are given a dial that here is a CPU, here is a memory, and your application needs to scale. Let's say your application becomes extremely popular, and then it needs to scale. It just scales. The cloud provider provides it. And we have lots and lots of customers who are doing some crazy amount of data on AWS, and I'll talk about some of those. When you're deploying your application in the cloud, then you're also looking at it, how do I make my application highly available? What that means is I don't want a single point of failure. In AWS, we have this concept of a region, which is a physical location around the world where we cluster our data centers together. And then within a region, we have multiple availability zones. So the customer, when they're building their application, they can deploy the application over there, and then it can make it highly available by scattering over those multiple availability zones. But again, as a customer, you are responsible for doing that. So for example, if you're building a container-based application, you will be doing that. In serverless, it is highly available by default. You deploy an application to a region, and we make sure that it is scattered across multiple availability zones. If something happens, your application does not go down. That, to you, is the most important part as a customer. And last but not the least, this is where serverless really shines, where you don't have to pay for an empty cluster sitting there and doing nothing. You only upload your code, and then you only pay for the time that the code is running. So these are sort of the 4 core tenets of what serverless is and how we see serverless evolving in the industry. There are lots of different flavors of this, but these are essentially the 4 core tenets. Let's talk about how we see the adoption patterns across a wide range of customers that we have seen. Okay? Now, on the bottom left is where your legacy architectures running in your on-prem data center, typically monolithic application. So what you want to do is you want to modernize them. Like any particular quadrant, if you were to see, you want to get to the top right. You want to get into the cloud, and you want to have agility for your application. Okay? How do you achieve that? So what customers do is they lift and shift the application in the cloud as first step, where I'm not going to take care of my data center. My data center lease is expiring. I cannot keep up with the pace of innovation that's happening. GPUs, whatever you need, I can't handle that on my data center. I run out of capacity in my data center, so I'm just going to lift and shift it into the cloud. Okay? Dow Jones is one of the customers of AWS, which moved to the cloud, and they saved a global savings of $100 million just by doing lift and shift. Once you have gone to the cloud, then you can say, OK, now I can start leveraging, for example, containers. And I'm talking about AWS here because that's where I work, but essentially, this would work across any cloud vendor. Okay? Then I can start leveraging some of the services to do the migration within the cloud to the containers. Okay? So that really gets you to the top right. An alternative approach is wherever you are running your application, you package it as a container, and then you move to the cloud. So a lot of customers do that route as well. So maybe you start converting into Docker image, deploy them on on-prem Kubernetes cluster, and you're ready to go global, and you deploy in different regions around the world. You quickly take it up and move it to the cloud, run it on an Amazon clusters, Amazon EKS service, and that gets you nirvana. And then there are customers who said, we're going to skip all of that. We're going to do that transition in one shot. We're going to just jump to the cloud, and we're going to start looking at serverless right away. So this is one of the typical patterns that we have seen on how customers are adopting serverless. Let's look at the second pattern that we have seen. The second pattern is around, you have an IT shop. In that IT shop, you run this job once like every day, once every few hours, and you don't want to maintain a cluster for that because that's not really efficient because you're paying extra cost for that unnecessary when the job is not happening. So what you do is you take that job, you set up a Lambda function for it, and once you set up a Lambda function for it, then you trigger it. That every time an event happens, somebody send me an email or a notification or an API, that Lambda function is called. And it's very easy because you set up a Lambda function. And by the way, the first million calls to a Lambda function are free every month. So it's very easy to get started. And that's how a lot of customers use it, because it's for life. First million calls are free. And if you're exceeding above that, then you can start thinking about, and the cost is not that prohibitive even at that point of time. Now, as you start doing the simple cron jobs to the Lambda function, then your department heads start looking at it. Oh, these jobs are getting a lot more efficient, and I'm paying a lot less money. Why not I take a particular application and start moving towards serverless? So this is a lot more organic serverless adoption. But at that point, when you start looking at it, oh, how can I be more agile? How can I look at the total cost of ownership? What is my scalability? So you start looking at all of those different aspects. Okay? So that's the second adoption pattern that we have seen. And the last one really is where, as a developer, what gets me excited is called as incremental refactoring, or the strangler pattern. Now, in terms of a strangler pattern, this was created by Martin Fowler. And he basically saw those strangler vines on the coast of Australia, where he was visiting on a vacation. And he says, it's funny how these thought leaders, they go on a vacation and then they strike a moment that, oh, this could be a microservices design pattern. So he built that design pattern, basically. But the idea is you are sitting, the strangler vines grow on the top of a tree. They grow down to the root, and they go down until they take over the tree, and the tree is no more. The vines become the tree. Okay? The vine becomes the host of the tree. So the strangler pattern, or incremental refactoring, is where you have one big monolithic application. Now, in that monolithic application, you identify a piece of functionality, you chip it out, and you expose an API for that, and then you create that as a single microservice. And then you chip out another piece of functionality, and another, and so on. And that way, your one big monolithic application, you start breaking apart. One big bang is typically not possible, not resource-wise, time-wise, constraint-wise. But so you start chipping out one functionality at a time, and then eventually your one big monolithic works over multiple microservices. And the process, as we have worked with customers, depending upon how much time and resources you are putting over there, could take anywhere from 6 months to 2 years, depending upon the size of the monolithic application, depending upon the organizational alignment that you're doing, and all those goodness. So let's take a look at it. How was this thing created, really? Now, roughly 90 to 95% of our AWS roadmap is driven by customers. So we look at what customer needs are, and that basically defines 90% of our roadmap. About 10% is what we'll think about what customer want. Okay? And this is one of the things that we looked at. Nobody asked us for Lambda functions or serverless, but this is something we thought of that, hey, this is what customers want, so let's create something on that. Now, AWS Lambda is a service that is available across all different regions. Now, one of the customer examples that I want to quote here is FINRA. FINRA is a financial regulatory industry in US. Roughly 99% of equity trades goes through FINRA, and about 65% of options trade goes through FINRA. And for each trade that goes through FINRA, they run about 200 rules. And guess what that calculates to? In a day, that calculates to about 500 billion with a B. It calculates to about 500 billion validation rules every day. Now, before they jumped on AWS Lambda, they were getting about 3-minute response time on average, and about 7-minute response time during peak. Jumping on Lambda, they could get, first of all, infinite scalability, and consistently a minute of response time. So I think that's the key part. That's the scalability we talk about all the time. And that is just one of the cases, but then you are seeing this all around the place. So now, let's say you're kind of getting the basic concept of what serverless is. How do I edit and debug my serverless application? So that is the fundamental part. As a developer, how do I get started with it? Okay, that's the first question that comes to your mind. So we believe community is a very incredible driver for innovation. So we like to work with the community out in the open source. So we announced something called a serverless application model. So what you do is very easy for you to get started, but essentially what it does, it provides you a DSL by which you can write your simple application. It's a very template-driven application. If you think in terms of serverless, what should you need? You need a function, multiple languages. You need an API by which it will be invoked. You need possibly a database. And you need an application, which would have like multiple of those functions composed with each other. So we provide a templating language which can cover all of those different types. And this is fully done in the open source. So you can take a look at it, serverless application model, on how easy it is to get started. Now, as a developer, I am like a Java developer, or like a Ruby developer, or a Go developer. How do I get started? So, well, there is Cloud9, which is an AWS product up in the cloud. So you can fire up Cloud9, do all the development, debugging, editing up in the cloud as well. But we also introduced the integration with all the cool tools. And IntelliJ is particularly relevant because they're headquartered in this part of the world, so that's very relevant. Now, I'm going to show you how easy it is to get started with creating a serverless application using IntelliJ. All right? Let's take a look. So what I have here is IntelliJ. Okay? I'm going to create a new project here. And this is an AWS application. Now, as version 1, what I'm creating, this is the AWS toolkit for IntelliJ. This is the usual IntelliJ toolkit, and all I've done is I've gone and installed from the marketplace the AWS toolkit. As version 1, what we're creating is a serverless application. But the goal is to add other AWS technologies so that it's easy for you to get started with them. So I'm going to make a simple serverless application here. And I'm going to say, hello, Minsk. Okay? So we type that. And I'm using Java 8. I'm using Maven-based application. I could change this to a Gradle-based application if I need to. Then it has some more settings. I don't worry too much about it. Click on Finish. So all I did is I just typed the project name, and it's going to generate a Maven-based project for me, and it will allow me to get running with this application. Okay? So let's make this window a little bit bigger here. So now if I look at, say, hello Minsk here, here is my hello world function. And if I look at my source here, this is my main directory. I can start expanding it. And if I look at my app.java, this is my simple application. Very easy to get started with. Nothing fancy here if you walk you through the code. But essentially, this is your request handler if you were to get started with your function, because this is where the request comes in. All you're saying is, this is my object here. Get my object. Here is my more details about the context. And then this is where I'm preparing my response. And all I'm returning is a hello world, as we do for all applications that we start with. Okay? Now, what I need to do is I'm going to go to Maven, and I'm going to enable this application in the Maven world. So I go to Workspaces, hello Minsk, pick this here, select pom.xml. So this application is now enabled as a Maven application here. And you see, as soon as you enable it as a Maven application, an icon appears on my IntelliJ itself. So now in IntelliJ, what I can do is I can click it. I can either run the application locally, or I can deploy the application to the cloud very seamlessly. What does it mean running locally? Because Lambda is running in the cloud, so how do you do that? Well, so what we do is we have a partner which created a Docker runtime for Lambda. So we download that Docker image for you, and we run that image locally for you. And that's how we run your function locally as well. And if I were to say, create this Lambda in the cloud, then of course it'll deploy the function up in the cloud, and then it's a lot easier where all the resources are consumed in the cloud as well. So let's take a look on what does it take to run it locally. So I'm going to run locally here. So it's saying, OK, you're going to run it. What kind of, it's asking me runtime, handler automatically picked up. If I have an AWS account pre-configured, it'll pick those values here automatically. I just need to provide the input value. In this case, is empty, because I'm not sending a request. I'm just getting a hello world response back. So I'm going to say run. Now, when I run, at this point, it's not showing me the output very clearly, but that's a bug that I've already filed. But you see this window at the bottom here, but that's essentially where it's doing the packaging. So it's packaging the application as a Lambda function so that it can run it locally, and then it can show the results. And now it's saying credentials found, and it's fetching the LambCI Lambda. And if it's the latest image, then it will download that. And once that image is downloaded, then it will run my Lambda function locally and show you the results. So very straightforward. Well, hopefully this will download, because the internet speed, we had an issue with the internet connection. But once the image is downloaded, it will run. Now, let's take a look. What does it take to run it remotely? So now here itself, I can say create new AWS Lambda function. And now I can start giving it a name, hello Minsk. And you can see the updates are happening behind the scene here. So I can give it a description as well. Being a Java function, I don't think 128 megabyte memory will work. So we'll have to bump up the memory here. So let's take it to about a gigabyte here. And I can specify the timeout as 60 seconds. I need to specify a Lambda role. So if you have done like a Lambda function already, and it'll create a simple Lambda basic execution role. And if you want to do distributed debugging, because typically you don't create one Lambda function as your application, you will have multiple serverless functions sitting up in the cloud, and your application logic is executed. It'll go through different Lambda functions. So you want to have that end-to-end visibility across your application. So if you want, you can actually enable X-ray, and that's one of the services from AWS as well. And I need to pick a bucket. That's where it's going to deploy my Lambda function, because that's where the source code is going to be uploaded, and say create function. Okay? And by the way, here, when it ran locally, it showed hello world as the output for me. So that's kind of cool. And now I can look at my AWS Explorer. Okay? If I look at my Lambda function here, and that's my hello Minsk function that we just created. So let's see if I can try this here. So if I go to, say, console, OK, I don't think I'll go there. I need to access password and all those things. But this is where exactly your hello Minsk function would be available, and you'll be able to show this in the Lambda, in the AWS console itself. Okay. Now the thought comes to your mind that, all right, that's how you run like a simple serverless function. One of the features that we introduced in Lambda, for example, last year is concept of layers. Now think about when you're creating a serverless function, does that mean that serverless function has to be fully packaged up with all the dependencies, all the binaries together? That makes that function a lot bulky. So think about, you have the logic that sometimes need to be reutilized. So in this case, for example, the business logic is very tiny, but you have library A and B that is duplicated across multiple Lambda functions. So how do you handle that? So we introduced this concept of Lambda layers, where you can grab that library A and B out as a separate layer. You provision that as a separate layer, and then your Lambda function itself becomes very tiny. It only has what it should have, which is the business logic. And then it can start referring to those as different libraries. Now, using that same concept, we also introduced the ability by which you can run your Lambda function in a wide variety of languages. So for example, Node, Go, Ruby, Java, the usual languages that developers care about are already supported in there. But we also added support for C++ and Rust runtimes. So if you are like a C++ or a Rust developer, you can actually run those Lambda functions very easily. And the beauty of that is those runtimes are actually built into open source. So you can take a look at it exactly how those runtimes are created, And if you want to create, say, a Fortran runtime, you can do that. Or a Pascal runtime, you can create your own runtime. People have created actually COBOL and PHP runtimes with that very easily. So it really depends upon what you want to do over there. But this is a good source code to look at and follow along, basically. Another part you want to think about, as we talked about, typically in your application perspective, you don't have one Lambda function. You have multiple Lambda functions. And the key of the Lambda function is the function by itself is a business logic, but it needs to be triggered by something that, there is a message, there is an API call, there is a queue, there is a notification somewhere being received. So that's sort of how the Lambda function is being triggered. So that's where you need to start looking at it, how my flow of the application is going to look like. So you need to have a mechanism by which when you're building your serverless application, all of this needs to be well connected with each other. So we have a service called as AWS Step Functions, and there are similar services as well by other cloud providers. But essentially, it provides integrations with a lot of different services by which you can very seamlessly and easily integrate in that entire ecosystem on how I want to build my simple serverless application. Something else, so we talked about the functions so far. And similar set of capabilities also exist in other cloud providers. Some more, some less, some different extent, and they all have their own different variations. But how can this concept of serverless be applied to other services? So we did this thing called as Aurora Serverless. Aurora is the fastest growing service of AWS. It's a database, basically, where you can have like a MySQL compatible or a Postgres compatible database. But you have this Aurora Serverless, which you may not want to run your database all the time. Well, often you do, but if it's a burstable load, if it happens once a day or once a week, what's the point of keeping your database up? Very much like servers, what's the point of keeping database up and paying the full cost of it? And that's where your Aurora Serverless kicks in. So you configure your Aurora Serverless. From your application, you provide the URL to it. Every time your Lambda function wakes up, it'll wake up the database, it'll do the business logic that needs to be done, and it'll terminate the database. And again, you are paying only for the execution time for it from the database perspective as well. And that truly makes your application as serverless. It's not just the function, but is the database aspect of it as well. How many of you are building applications with some sort of containers today? Yeah, about 30% of you. So, serverless is cool, but a lot of customers have barely started getting grasp of what containers are. Some sort of a Docker, some sort of a Kubernetes, they're doing it. So how does this concept of serverless can now be applied to containers? We literally started getting a grasp of it. So as we discussed earlier, containers make it easy to build and deploy your applications very easily. Now, it's very easy to get the application up and running on your local laptop, but typically your application, if you're using containers, is lots of containers. So you need like an orchestrator, like a Kubernetes or some other service that is running in the cloud where you can manage your clusters over there. But the key word over there is you still need to manage a cluster. And managing a Kubernetes cluster is not easy at all. Okay, so if you think from a broader cluster perspective, running containers essentially. So what you have is a control plane and then a data plane. Data plane is where all of your containers are running. And then there's a control plane sitting on top of that because control plane is the one that manages the data plane. And there are a few key components that you need in the control plane. There is something called as a cluster manager because essentially if you have a cluster of nodes, you need to manage that cluster. If a node goes down, bounce it back up. You need a scheduler. How do you know which container to be scheduled on which node? And then you need a controller, which will make sure that if a container goes down, it can bring it back up again. So those are sort of the key components of control plane. And then from a user perspective, you talk to control plane, which then manages the data plane for you. Okay? But if we go back to the sort of the serverless paradigm, I still need to manage this cluster. I still need to run sort of my Kubernetes cluster and manage that cluster. And my scalability of my containers is limited by the cluster size, essentially. So again, as we were talking to customers, customers were saying that, hey, we need to focus on the application. We don't want to focus on managing those clusters. So we introduced this service called as AWS Fargate. Okay? What Fargate does is, very much like Lambda, it gives you those knobs. It says you choose the CPU and the memory requirement. You don't have to manage the cluster. You bring a container, and we will run the container for you. We will manage the cluster for you, very much like Lambda or Serverless. Okay? So there are 40 different variations over here that you can take a look at, and it easily gets started. So essentially, you can use, say, any of the services on the top, ECS or EKS, which is our managed Kubernetes service. Then at the bottom, if you have a data plane like this, that data plane essentially is managed by Fargate. And that's where your containers are running. So from your perspective, you bring your container, you run your container in the cloud, and we manage the container for you. Again, you pay only for the runtime, nothing for the cluster that is running behind the scene for you. And that is very similar to how, say, Lambda functions are run as well. There's a control plane, there's a data plane. You just don't see it behind the scene. Now, this is sort of a good analysis on how customers look at it. We always talk about shared responsibility. So depending upon the range on where you're doing it, so let's say you're running using EC2. So what we do is we take care of the physical hardware, the infrastructure. We abstract the hardware part of it for you. We give you a virtual machine, and you start with that virtual machine. But then anything and everything on top of that, the version of the operating system, the application stack, the container version, everything, scaling is all your responsibility. Similarly, you can keep going above the stack. Say, I want to use a managed container orchestrator, or I want to do a Lambda functions or serverless. And at the top, if you see, that's where the serverless functions are, where the cloud provider would manage everything that you need from the infrastructure perspective. And as a developer, what you're focusing on is exclusively on the Lambda functions or your application logic. And that's what really matters to you, because that's what makes you a lot more productive. Now, even though we started sort of this serverless function category, but there's a lot of innovation that is happening in the industry as well. So CNC, I'm Amazon's representative for the Cloud Native Computing Foundation. So I sit on the board, and I work with a lot of customers over there on helping them to be successful. There is a serverless working group in CNCF where a lot of discussions happen on what serverless should be called, what it should look like. And last year in KubeCon Seattle, they presented a white paper that kind of provides a little bit broader spectrum from a vendor-neutral perspective. So I highly encourage you to read this. And what they also created is called as serverless landscape. So if you think from a serverless perspective, from a wide variety of perspective, well, we got platform, frameworks, and tools, and security aspect of it, okay? So what they've done is they've picked different open source projects, different vendor projects or products, and they have classified them in different ways. So this is typically what customers are using when they're looking at different serverless options. I want to get started with it. This is a good starting point for me, because then this gives me a wide range of choices. I don't want vendor lock-in. I get it. Take a look at this, but then make your choice wisely. Think about the features that really matter to you and that you would really read in the long run. Another key initiative within CNCF is very important. Now, think about Lambda function once again for a second. There are a lot of services that can trigger a Lambda function. Okay? Now, I could store a document in a S3 bucket that will trigger a Lambda function. Or I could have Alexa do something for me, and then it will trigger a Lambda function. So essentially, if you think about it, Lambda function becomes sort of the glue between these different services. And that is not just true for AWS. If you think about it, other cloud providers have similar gluing capability as well. So they have their functions, so like Azure functions or Google Cloud functions, and they have their set of services, storage, database, API, gateway, whatever it is, and they provide similar glue as well. Okay? Now, if you're looking for an environment where you're doing deployments across multiple clouds, how does it work? What if I wanted to deploy a Lambda function and invoke that Lambda function when somebody stores on a storage of a different cloud provider. Or if I store something in S3 bucket and I want to call a Lambda function equivalent on a different cloud provider, how does that work? So an initiative that is happening in CNCF that you should be aware of is called as cloud events. Cloud events is a specification that the serverless working group has been working on, and that essentially is going to define how across clouds you can send events. So it's defining different data formats, it's defining protocols, and as you can see, the version of the specification is very early, 0.2, but that means this is a really good time for you to get engaged and involved into this. So if this is something that matters to you, that, hey, you know what, I really care about how my Lambda functions and other providers would work, this is where all the work is happening. Let's stretch a little bit ourselves, okay? So this is good that we have basic containers and functions and all those things working. What can we do on the infrastructure side then, okay? So let's take a look at that. Now, when we look at sort of how we run Fargate function, okay, let me talk about that for a second. You ask us for a, well, if you think about containers in general, there is no such concept as a container. Container is nothing but a set of concepts that are put together in Linux. So C groups, namespaces, all together is basically what compose a container, okay? Now, containers are not meant to be run in a hostile environment, or there are regulatory issues where a bank would not like to run a container with somebody else on somebody else's hardware. That's very common. We see in our customers. But if you think about Fargate, so the way we do this is you bring a container to us, you say, run this container. So we match the nearest EC2 instance. We bring that EC2 instance from a warm pool, and we run the Fargate task over there. You want it to scale, we bring more EC2 instances. So essentially is one Fargate task per EC2 instance. But that's not very efficient, because if you look at Fargate, we can ask for a lot lower CPU memory requirements, but the EC2 instances don't necessarily match. So that's not very efficient. So we started looking at different options that are available in the industry, and what is it that we can do? What kind of virtual machine manipulation we can do? What can give us better utilization, essentially? So as a result, last year we launched an open source project called as Firecracker. Firecracker is an open source virtualization technology. Now, this is based upon KVM, and what it gives is the ability by which you can create a micro VM, not a VM, and the reason it's called as micro VM, I'll get into that in a second, but it basically gives you security and isolation of a traditional virtual machine, but it gives you the speed and density of a container. It's purely KVM based and is a good isolation boundary, okay? So what you can do is, from an infrastructure provider perspective, you can create like a micro VM, and now you can run a Fargate task or a Lambda function in that micro VM. So instead of creating multiple EC2 instances, one for each container, we can have one big bare metal machine, and in that big bare metal machine, we can run multiple Firecracker micro VMs and provision each container or each Lambda task in a micro VM. And that gives us a lot more efficiency and utilization of the resources. And as we have done is, over the years, every time we get more efficiency, we pass the cost back to customers. We have done that over 70 times. So earlier this year, we reduced the cost of running Fargate in the cloud, because Fargate is going to be based upon Firecracker. So we reduced the cost of running Fargate containers, which is serverless containers essentially, by almost 50%, and depending upon the case that you're looking at it. And this was purely developed at Amazon because we felt the need of why this needs to be done. So let's take a look at it a little bit more in details of Firecracker. And this is purely done in the open source, so I would highly encourage to engage with us. So Firecracker, it has a minimal guest kernel configuration and a fast boot up time. It also has a very low footprint. It has it has two devices, vert.io and vert.io block. It has a single-digit keyboard, and that is basically used to terminate the machine, essentially. So the overall footprint of the micro VM is very small, and that makes it that much more secure, because the smaller the area that you can target, the more secure it's going to be. It's built for speed. So if you think about it, each micro VM can be launched in less than 125 milliseconds, as opposed to a VM, which could take a few seconds, if not a few minutes, to launch. So essentially, you can fire up quickly, and then you can do up to 150 micro VMs per second. So our goal is that we want to run AWS Lambda using Firecracker micro VM at the backend technology. That's the goal that we are working towards. And the memory footprint of each micro VM is less than 5 megabytes. So it's not a lot of overhead. And that is exactly what gives us the efficiency and the scaling capability, because now on a big bare metal instance, we have the isolation boundary that is required, because this is KVM based. So we get the hardware based virtualization, and we get the security, and we get the density as well. So that is exactly sort of what we are working towards inside of the serverless land. Now, Firecracker is truly a foundational technology. That's not, I mean, like the way you create a VM, you would not create a micro VM like that. It is really meant for to be a foundational technology for other orchestrators to build on top of this. So from AWS perspective, yes, we want to do Lambda and Fargate on top of this. But as soon as we announced Firecracker at reInvent last year, Kata Containers is an OpenStack technology, and they have been working on a similar mission for a couple of years. So Kata Containers allow you to run containers, in using a micro VM concept as well. But they use QEMU as a virtual machine monitor. And QEMU is a little bit, full functional, fully featured micro VM. And the Kata Containers folks has a long-standing request that we want a minimal micro VM. So as soon as we announced Firecracker, they were super interested, super excited, and they asked us to partner with them, and we worked with them. So essentially, when they launched Kata Containers 1.5 earlier this year, they actually had an integration with Firecracker. And something else that we are also working on is the Firecracker and Containerd integration. Now, Containerd is how you run, say, your Kubernetes cluster, which is deep down is an underlying layer on how Kubernetes containers are invoked or Kubernetes pods are invoked. So we are also actively working on Firecracker and Containerd integration. So think about when your pod is running, that pod could essentially run in a micro VM running on a bare metal machine. Again, giving you a lot more efficiency and utilization. Now, this is Werner Vogels, who's the CTO for Amazon. And the way we think about serverless, essentially, is exactly like this. That from an application developer perspective, anything and everything you should be doing should be all about your application. You should not be worrying about building a cluster, running a cluster, managing a cluster, scaling a cluster, not even scaling your application. The cloud provider should give you the ability that, hey, application becomes popular, just scale it. I need to deploy to a different region. Yeah, sure, go for it. Allows you to go global as well very easily. So that's exactly the kind of concerns and the constraints that you should be thinking about, as opposed to from the infrastructure perspective. So really, my only request here is we would like you to be builders. We like to be builders. I like to build applications. So I would say go ahead and build your applications. And that's sort of the end of my keynote. If there are any questions, I'm happy to take them.
Thank you. The question is, how did you manage to run Lambdas before Firecracker has been introduced?
Yeah, so we have before Firecracker, it runs on inside EC2 instances, and we use containers, again, Linux containers behind the scene for that. But that technology is not open source, and that is completely sort of within Amazon itself. But now the goal is we are working towards to run Lambda functions on Firecracker. And as I said, it's going to give you a better utilization of resources in general. And so that's something that we are constantly looking on how we can improve our hardware, infrastructure, and provisioning mechanisms.
Hi, thank you for the speech. So I have a question. As a simple developer, I prefer to write code, to cover it with tests, to load it on my local host, and to debug it. So talking about Lambda functions, is there any way to load it on local host, test it, and only then deploy it on AWS? Or I must deploy it on AWS, read logs, and only then I can see that the logic is correct?
Yeah, no. So the question really is that, do I have to deploy it on AWS, or can I, as a developer, can I do this testing all locally? So the example that I showed with IntelliJ, where I built the function, I ran the function, that was all done locally. So if you think about it from a developer perspective, so see, if you see here, what we were doing is we were downloading a Lambda Java 8 Docker runtime. And this Docker image is downloaded on your local machine. And this is exactly where you can mimic, oh, I'm running everything locally. So if you are in a flight, or if you're in an office, or if you don't have internet connectivity, that still gives you the ability to test the function locally. To the point that you can even mimic an API gateway as well. So build a Lambda function, say, hey, this is how my API is going to look like. Test all of that locally very easily. And you can even debug this function. So if I go here, for example, I can set up a breakpoint here, and now I can say, go debug the function. So I can start doing the debugging here internally, show the complete state of my function. And once you have a good confidence that this works, then you can say, now go ahead and take this function and create a new Lambda function for me. And this will automatically deploy it for you. Behind the scenes, what's happening is packaging up the function and is putting it into a S3 bucket. And once it's in the S3 bucket, it takes that and deploys it into the Lambda function. So since we have time, so let me actually log into the console here. So I'm into the console here. So if I look at Lambda here, and this is sort of my hello Minsk function, okay? And it says it is deployed 26 minutes ago. So if I click on this now, so I can see everything that is available over here and how I can do a simple, if I want to simple invoke this function, I can click on test here, and I can say, go ahead, invoke it, like this, okay? I give it the payload, then it creates the payload. So I call it as test, for example. I create the payload, and now I can say test it with that payload. So now I'm running it. So whatever you're doing on your local desktop, you can do it in the cloud as well. But I understand it is important to do the local development experience. And that is not just possible with IntelliJ. You can do that with Eclipse. You can do that with Visual Studio. You can do that with PyCharm, any of that.
Thanks, Arun. We need to start preparation for the next talk. If you have any more questions, please reach to Arun anytime. Thank you.
Thank you.